Hello everyone! This is the third video in a series on exponential growth. In the first videos I explained something about factors and how you can use them. In this one we are going to have a look at actual exponential growth. First of all, I will explain to you what exponential growth is, and then I will explain how you can recognize it. Now, exponential growth has a specific issue with rounding off, so we will also look at how you can recognize it with rounding off. And I will end with some examples in real life of exponential growth. But first of all, what is exponential growth, or what is an exponential relation? Before I get to the exponential relation, I first want to have a look at a linear relation, which is something we've seen before. So in this table we have a linear relation because every step of the way we add 3. From 4 to 7, from 7 to 10, from 10 to 13, and from 13 to 16. And this number is what we called the gradient. Now, an exponential relation is in a way similar. We can again put it in a table, but instead of adding the same thing every time, we are multiplying by the same number every time. So in this case, every time it's multiplied by 2. So from 3 to 6, from 6 to 12, from 12 to 24, and from 24 to 48. And you may remember from the previous videos, if you multiply by something, it's called a factor. So this number, this 2, is called the growth factor. Now, how do you recognize this? Whenever you have some situation, you have a table with it, and you have an assumption that it may be exponential, then what you have to do is you have to check each and every step of the way, each and every step in your table, each and every arrow. You have to see whether they're all the same, whether they have the same growth factor. And the way you get that growth factor is dividing the new number by the old. So the first growth factor is 40 divided by 80, which is a half. So this one is times a half. The second one, from 20 to 40. From 40 to 20, so we divide 20 by 40. So again, we get a half. And if we continue this, we get 10 and 20, so from 20 to 10, we also get a half. And from 10 to 5, so 5 divided by 10 also gives a half. Every growth factor is the same, so we indeed have an exponential relation. This is how you can check for an exponential relation. But as I mentioned, sometimes the values are rounded off. An example is with money. Here I rounded off to full whole numbers. But generally, money only has 2 digits after the decimal point. We don't care beyond that because we don't have anything after cents. So in the case of money, it will always be rounded off to some extent. So let's have a look at this example. And if we divide 155 by 150, we're going to get approximately 1.033, which continues. If we take the second step, 159 by 155, we get around 1.025. And if we continue this, we check all of them. We get slightly different growth factors every time. Oh, made a small mistake. There we go. So it may seem like it's not exponential growth. However, the values are all very, very close to 1.03. And as it turns out, if I take my 150 and I multiply it by 1.03, I will get approximately 155. If I multiply it by 1.03 again, I will get approximately 159. If I repeat this, I get 164 and then 169. So it is an exponential relation with growth factor 1.03. But you don't see it immediately. You have to check every step of the way, then figure out what is it really close to, and after that you have to check, does it work every time? Does it give me that rounded off value? So that is a special case for exponential relations. Now, last but not least, let's have a look at a few examples of exponential growth, some examples that we actually find in real life. The first one has to do with money again, just like the previous example, which is interest. On your bank account, you may get 2% interest, which means you get an extra 2% of money from the bank every year, meaning you have a factor of 1.02 every year. First year it's times 1.02. Second year it's again times 1.02, etc., etc. So that is one type of exponential growth. The other ones are slightly more scientific, but also have a lot to do with biology. So for instance, if something is radioactive, then it will slowly decay, and that has to do with a certain half-life. After a certain time, only half is left. After that same time, it is halved again, and it constantly halves, which means you constantly use a factor of a half, of 0.5. The same goes for medicine in your blood. Many medicines get filtered out of your blood quite slowly, and they halve over a certain time. So then again, it's times a half, times a half, times a half for a certain time. Of course, we can also go the other way around. If we have a look at, for instance, bacterial growth, then how fast it grows is defined by how long it takes for it to double, which means that after that time period, maybe it doubles every hour. If you start with 10 bacteria, then after an hour you've got 20, after 2 hours you've got 40, 80, 160, etc. It's constantly multiplied by 2. And last but not least, which is kind of the same but then for animals, population growth is also exponential, or at least to a certain extent. At some point it stops, but for a short term you can say that it multiplies by a certain amount every year. So especially in biology, but also in other sciences, exponential growth comes back a lot. It's a very natural type of growth. In the next video, we are going to see how we can actually turn this into a formula that we can work with.